Science achieving energy sustainability. What's one good way to do that? I'm trying to give you a clue here. In energy resources and consumption, it's four parts. First, conservation, efficiency, and renewable energy. And then we're going to talk about biomass and water. And then we're going to talk about solar, wind, geothermal, and hydrogen types of energies. And then we're also going to talk about planning energy future. So in conservation, efficiency, and renewable energy, by the end of this, be able to describe strategies to conserve energy and increase energy efficiency, and also explain the differences among the various renewable energy types of resources. Well, even though you don't want to hear it, we can use less energy through conservation and increase the efficiency. A truly sustainable approach to energy use must be incorporating both energy conservation and the use of energy efficiency. So conservation and efficiency efforts, they save energy that can be used later, just as you might save money in the bank account that you can use later when your need arises. So in this sense, conservation and efficiency are sustainable as far as energy sources. Energy conservation and energy efficiency are the least expensive and most environmentally sound option for maximizing our energy resources. In many cases, it's also the easiest thing to approach and implement because it requires a fairly simple change to the existing system rather than switching over completely to new technology. We're going to examine ways to achieve both objectives here. Energy conservation means finding and implementing ways to use less energy. Increasing energy efficiency means obtaining the same work for a smaller amount of energy. So energy conservation and energy efficiency are closely linked. One can conserve energy, but not by using electrical appliances or doing doing things that result in the less energy consumption. But one can also conserve energy by using a more efficient appliance. One would do that the same way, and both of them would basically have the same result. The government can also facilitate the use of energy conservation by taxing electricity, much like oil and natural gas. Since higher taxes discourage people to use it, alternatively, governments might offer rebates or tax credits for retrofitting your home and business with appliances that would use less energy. Some electrical companies bill customers with what we call a tiered rate system, in which customers pay a low rate for the first increment of electricity, and then as their usage goes up, they continue to pay higher and higher rates. And all of these practices encourage people to reduce the amount of energy that they use. The demand for energy varies on the time of day, season, and weather. When electricity generating plants aren't able to handle the demand during these high use periods, brownouts and blackouts occur. So to avoid this problem, electric companies must be able to provide enough energy to satisfy what we call peak demand. And that's the greatest quantity of energy use at one time. Peak demand may be several times the overall average demand, which means that sustainability for more energy must be available than the need for the average condition. So to meet this peak demand for electricity, electrical companies often keep backup sources for energy, primarily in the form of fossil fuels. Sustainable design can improve the efficiency of buildings and communities in which we live and work. So this diagram shows some key features of sustainable design applied to a single family dwelling. Insulated foundation walls and a basement floor, orienting the house properly in relationship to the sun, and planting shade trees in warm climates are all appropriate design features. We've seen before, too, that good community planning also conserves energy. So building houses close to where residents work reduces the reliance on fossil fuels. And the use of transportation, which in turn reduces the amount of pollution and then carbon dioxide into the atmosphere. Buildings consume a great deal of energy for cooling, heating, and lighting, and so many sustainable building strategies rely on passive solar design, which is the construction technique designed to take advantage of solar radiation without the use of any active technology. This passive solar design stabilizes indoor temperatures without the need for pumps and other mechanical devices. So, for example, the northern hemisphere, if you live there, constructing a house with the windows along the south side wall allows the sun rays to penetrate and warm up the house, especially in wintertime, when the sun is predominantly in the southern sky. To reduce the demand for heating at night and for cooling during the day, builders can use construction materials that have a high thermal mass. And thermal mass is a property on the building of the building material that allows it to retain heat or cold. Materials with high thermal mass, they stay hot once they've been heated and cool once they've been cooled. And carefully placed windows allow for the maximum amount of light into a building to reduce the need for artificial lighting. Dark materials on the roof or exterior walls of the buildings, they absorb more solar energy than light-colored materials, basically furthering the warming of this structure. And opposite of that, using lightly colored materials on the roof reflects heat away from the building, which keeps it cooler. So in the summertime, when the sun is high in the sky for much of the day, an overhanging roof helps block out sunlight during the hottest period, which makes the indoor temperature cooler and reduces the need for ventilation and fans and air conditioning. In addition, window shades also reduce solar energy. Window shades can also reduce the need for energy use in the house. And so here's what I mean by passive solar design. Passive solar designs use solar radiation to basically maintain and regulate the indoor temperature of a home. And roof overhangs make use of seasonal changes in the sun's position to reduce demand for heating and cooling. When the sun is low in the sky, it shines directly into the window and heats the house. And in the summer, when the sun is higher in the sky, the overhang blocks the incoming sunlight. So high efficiency windows and other building materials with high thermal components can also be used to create this passive solar design. As fossil fuels become less available and more expensive, what's going to take their place? Probably it'll be a mixture of energy efficient strategies, like energy conservation and new energy sources. We've learned that conventional energy resources like petroleum, natural gas, coal, and uranium ore are non-renewable. And from like a system analyst perspective, fossil fuels constitute an energy reservoir that we're basically depleting much faster than we can ever replenish it. So, we have a finite amount of uranium ore available to use as fuel and in nuclear reactors. So, in other words, sources of energy can be generated or regenerated rapidly. Biomass energy is a source of potentially renewable energy because those are resources that can be regenerated indefinitely as long as we do not consume them more quickly than they're being replenished. Solar winds, geothermal, hydroelectric, and tidal energy are essentially what we call non-depletable. In the span of human time, no matter how much we use, there is always going to be more. So the amount of non-dependable resources available tomorrow does not really depend on how much we use today. Altogether, we call those things renewable energy resources. So this diagram illustrates renewable energy resources. Many renewable energy resources have been used by humans for thousands of years. In fact, before humans began using fossil fuels, the only available energy source was wood and plants, animal manure, and even fish or animal oil. Today, in parts of the developing world, there is little access to fossil fuels. So people still rely on like local biomass energy sources like manure and wood for cooking and heating. According to the U.S. Energy Information Administration, biomass is currently the source of 86% of all the energy consumed in sub-Saharan Africa, as much as what's what is not harvested for sustainability. But here we have the United States. And this shows renewable energy resources account for approximately 13% of the energy worldwide, but most of which is from biomass. In the United States, which depends heavily on fossil fuels, the renewable energy resources provide only about 7% of all the energy used. So that 7% is shown in detail here, and it comes primarily from biomass and hydroelectricity. So, to recap here, conservation and renewable energy, we've seen that to achieve energy sustainability, we should begin with conserving energy and increasing the efficiency of what we already have. And serve energy conservation refers to finding ways to use less energy. Increasing energy efficiency means that achieving the same amount of work for a similar quantity of energy. So, sustainable design of buildings and communities can decrease energy use. We also looked at the different categories of renewable energy resources, potentially renewable energy sources that can regenerate if we do not consume all that we have quickly, then we can replace it. And also non depletable energy resources like wind, which cannot be depleted no matter how much we try. So, next up, we're going to examine two important renewable resources: biomass and water. And those are used to generate electricity.